dear students. Today in our class we will discuss about thermodynamics, and we will try to understand some of the graphs that you are seeing here. First of all, we have a graph of isochoric process, and then isobaric process, and then isothermal process. Let me tell you what isochoric process mean. So isochoric means that our volume is fixed. Okay, so here volume is fixed, meaning that volume does not change. So if the volume does not change, then change in volume del V is 0. So in case of isochoric process, remember, volume does not change, hence del V is 0. Okay, so we have several graphs. We have graph of PV diagram, and here in PV diagram the graph is a vertical line. It's a vertical line. Why is it a vertical line? Because if you change the pressure, your volume does not change. Look at here. My pressure increases. Okay, I take different color. So let's say I take yellow. See, my volume changes, my pressure changes. My pressure is increasing, it is increasing, but my volume is not increasing. See, the volume is not increasing, it's not going anywhere. It's a vertical line, it's a flat vertical line, meaning that volume here is fixed, it is this value. So the volume is fixed, but the pressure is changing. So whether you change the pressure or not, that does not affect the volume. Didn't I say that in isochoric process, volume is fixed? So you can see that from this graph too, that you change the pressure, you increase the pressure, or whether you decrease the pressure, that does not affect the volume, that is fixed. So how about pressure and temperature? Well, it does change, pressure and temperature. You can see that it is a straight line, it is a linear line. Why is it a linear line? Let's try to understand that from the ideal gas law, PV equal to nRT. Here, if in case of isochoric process, my V is constant because it is volume. So if V is constant, if N is constant, and R is already a constant, then I can say that that pressure is proportional to temperature. If you increase temperature, your pressure will increase. If you decrease temperature, your pressure will decrease. Here in the graph, you can literally see that with the increasing temperature, the pressure is increasing. With the decreasing temperature, the pressure is decreasing. Okay, so how about the next graph? In this graph, you are changing the temperature. See, you are increasing the temperature, but the volume, which is along y-axis, is fixed. It is not changing. You decrease the temperature, the volume is fixed. It is not changing. The volume is fixed. The volume is always fixed. See, this distance, all are same from the x-axis. In order to master in graphs, you must practice by yourself. Okay, so let's talk about isobaric process now. So isobaric process means that our system, in this system, pressure is fixed. Okay, now pressure is fixed, meaning that the change in pressure is equal to 0. The change in pressure is equal to 0, right? So what does the graph tell you? You see, you change the volume, you go along this direction or that direction, that doesn't matter because our pressure is fixed. You see, this height is fixed, this is fixed. So whether you change your volume or not, see, I'm increasing the volume, this value is much smaller than this one. Now I am increasing the volume, but still my pressure, which is this height, is fixed. It is fixed. So this is the nature of isobaric process. From the graph, you can clearly see the pressure is not changing even if I am changing the volume. Hence, it is isobaric process. Okay, how about this one? With the increasing temperature, my pressure is not changing. I told you earlier that isobaric process means pressure is fixed. You can clearly see that in here. Okay, how about the last one? You see, from the ideal gas law, you know that PV equal to nRT, and as in the isobaric process, pressure is fixed, it is constant, and N is constant. Let's take N, which is the mole number. It is a constant. Let's consider let's consider it to be a constant, right? R is what we call molar gas constant. It is already a constant. It is a universal constant, right? So if P, N, and R, P, N, and R, all of them are constant. So you are left with V and T. And you can clearly see that T is proportional to V. So if you increase the temperature, your volume will also increase. How about you decrease it? Your volume will also decrease. So this is the nature of isobaric process. So now we will talk about our last topic today, which is basically isothermal process. From the name you can understand, iso means same or fixed, thermal means here temperature. So it means that my temperature is fixed. The system's temperature is fixed, which indicates that the change in temperature is 0. So what does the graph tell you? You see, PV equal to nRT. So here temperature is fixed, and N is already fixed, R is fixed. So PV is equal to some constant, right? From here you can say PV equal to constant divided by V. That means P is proportional to 1 by V. They are inversely proportional. You know what that means? If you increase V, P will decrease. If you decrease V, P will increase. And hence you give this graph. This is a hyperbola. And it is called a rectangular hyperbola. Okay, it's a special kind of hyperbola where eccentricity is basically equal to 2. And now we have the second graph, which is where you change the temperature, you increase or decrease it. That doesn't bother the pressure. My bad, extremely sorry, I said it wrong, I explained it wrong, right? I change my pressure. You see, I am increasing the pressure, I am decreasing the pressure. That does not change my temperature, not pressure. You see, the temperature value is this value, which is fixed. You don't see any movement in temperature axis. Do you see any movement in temperature axis? You don't, right? We don't see any movement in our temperature axis. We only see movement in vertical axis, which is pressure. Similarly, we see only change in vertical axis, which is volume. You don't see any movement in horizontal axis because temperature is fixed. You can't change the temperature in isothermal process, or you can say that in isothermal process temperature is never changed. So this is the explanation of these 9 graphs. Hopefully they are going to help you in preparing for your exams. Subscribe to my channel for more videos like that.